Lightning protection is not generally a mandatory requirement in the National Electrical Code for all structures. However, there are specific instances where it might be required, such as for structures housing flammable liquids or gases, or in areas with a high frequency of lightning strikes. When considering lightning protection for a structure like a library, it's essential to understand the scope and implications of installing even a partial system, such as protecting a weather vane. The National Fire Protection Association Standard 780, titled Standard for the Installation of Lightning Protection Systems, provides detailed guidelines for designing, installing, and maintaining complete lightning protection systems. This standard is not part of the National Electrical Code, but is often referenced by the National Electrical Code and is considered the authoritative source on lightning protection. Once a decision is made to implement any level of lightning protection, it's generally recommended to install a complete system adhering to NFPA Standard 780. A complete lightning protection system typically includes air terminals or lightning rods, which are the points of strike, conductors that carry the lightning current to ground, and grounding electrodes that dissipate the current into the earth. Bonding of metal bodies within the structure is also crucial to minimize potential differences and prevent side flashes. Implementing only a partial system, like protecting a weather vane without properly grounding it and bonding it to other metal components, can create a greater hazard. For example, if the weather vane is struck by lightning, the current could travel through the structure in an uncontrolled manner, potentially causing fire or damage to electrical systems. Firstly, air terminals, often called lightning rods, are strategically placed on the roof and other exposed areas of the building. These terminals are designed to intercept lightning strikes and provide a preferred path for the current to flow to ground. The placement and spacing of air terminals are determined by the height and shape of the structure, as well as the lightning flash density of the area. Secondly, conductors, typically made of copper or aluminum, are used to connect the air terminals to the grounding electrodes. These conductors must be of sufficient size to handle the high currents associated with lightning strikes. The path of the conductor should be as direct as possible, avoiding sharp bends or loops, which can increase impedance and cause voltage surges. Thirdly, grounding electrodes are buried in the earth to provide a low resistance path for the lightning current to dissipate. These electrodes can be ground rods, ground plates, or bare ground conductor loops. The number and type of grounding electrodes depend on the soil resistivity and the size of the structure. The goal is to achieve a low ground resistance, typically 25 ohms or less, to ensure that the lightning current is safely dissipated into the earth. Bonding is also an essential component of a complete lightning protection system. Bonding involves connecting all metal bodies within the structure, such as metal pipes, ductwork, and electrical conduits, to the lightning protection system. This minimizes potential differences between these metal bodies and prevents side flashes, which can occur when lightning current jumps from one metal object to another. Surge protection devices, or SPDs, are often installed as part of a comprehensive lightning protection system. SPD are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. They are typically installed at the service entrance of the building and at various points throughout the electrical distribution system. The National Electrical Code addresses surge protection in Article 230.67, requiring surge protection for dwelling units, and Article 708.20, covering critical operations power systems. While the National Electrical Code does not mandate lightning protection systems in most cases, it does provide requirements for grounding and bonding, which are essential for any lightning protection system. Article 250 of the National Electrical Code covers grounding and bonding requirements, including the size and type of grounding conductors, the installation of grounding electrodes, and the bonding of metal bodies. It is important to consult with a qualified lightning protection system designer and installer to ensure that the system meets the requirements of NFPA Standard 780 and the National Electrical Code. These professionals can assess the specific needs of the structure and design a system that provides adequate protection against lightning strikes. When adding lightning protection to an existing structure, it is important to consider the potential impact on the building's electrical system and other systems. The lightning protection system must be properly integrated with these systems to avoid creating hazards or interfering with their operation. For example, the grounding system for the lightning protection system must be coordinated with the grounding system for the electrical system to prevent ground loops and other problems. In summary, while the National Electrical Code does not generally require lightning protection, it is recommended to install a complete system adhering to NFPA standard 780 once any level of lightning protection is implemented. This includes air terminals, conductors, grounding electrodes, bonding, and surge protection devices. It is also important to consult with qualified professionals to ensure that the system is properly designed, installed, and maintained. Ignoring these recommendations can potentially increase the risk of damage or injury from lightning strikes. For a library, the decision to add lightning protection should involve a careful assessment of the risk of lightning strikes, the value of the building and its contents, and the potential consequences of a lightning strike. A comprehensive risk assessment can help determine whether lightning protection is necessary and, if so, what level of protection is appropriate. Factors to consider in the risk assessment include the location of the library, the height and shape of the building, the presence of trees or other nearby structures, and the frequency of lightning strikes in the area. The cost of installing and maintaining a lightning protection system should also be considered, as well as the potential cost of damage or loss due to a lightning strike. If the risk assessment indicates that lightning protection is warranted, a qualified lightning protection system designer should be consulted to develop a detailed plan for the system. The plan should specify the type and location of all components, as well as the installation procedures and maintenance requirements. It is important to choose a designer and installer who are experienced and knowledgeable about lightning protection systems and who are familiar with NFPA standard 780 and the National Electrical Code. The installation of the lightning protection system should be carefully supervised to ensure that it is installed correctly and that all components are properly connected. After the system is installed, it should be inspected and tested to verify that it is functioning properly. Regular maintenance is also essential to ensure that the system continues to provide adequate protection. This includes inspecting the components for damage or corrosion, tightening connections, and testing the grounding resistance. The specific maintenance requirements will vary depending on the type of system and the environmental conditions. In addition to protecting the building and its contents, lightning protection can also help protect people inside the building from injury. Lightning can cause serious injuries or even death if it strikes a person directly or if the current travels through the building's electrical system. A properly installed lightning protection system can reduce the risk of these types of injuries. It is also important to educate people about lightning safety. This includes advising them to seek shelter indoors during thunderstorms and to avoid contact with metal objects or water. People should also be aware of the signs of a lightning strike, such as a sudden flash of light or a loud clap of thunder, and they should know what to do if someone is struck by lightning. In conclusion, while the National Electrical Code does not generally require lightning protection for all structures, it is an important safety measure that should be considered for buildings like libraries. A complete lightning protection system designed and installed in accordance with NFPA standard 780 and the National Electrical Code can significantly reduce the risk of damage, injury, or loss due to lightning strikes. It is important to consult with qualified professionals to assess the risk, develop a plan, install the system, and maintain it properly.